Hello, this is Eric Ahrens with the University of California speaking about Excel for business statistics. This is one of my classroom activities in which I extend discussion of probability into factorials and combinations and related functions of Excel. I will include examples from casino gaming. Let's begin with definitions of math functions related to combinations. Probability is a value between 0 and 1 that describes the relative possibility an event will occur. We often see probability expressed as a percentage between 0 and 100. Factorial is the product of all the positive integers from 1 to a given number. The formula is n factorial equals 1 times 2 times 3 up to n. By definition, 0 factorial equals 1. The gamma function is an extension of the factorial function. We use the Greek symbol for capital gamma, so gamma at n equals n minus 1 factorial. For combinations, we often say this as n choose k. This refers to selecting n things k at a time without repetition. So n choose k equals n factorial divided by k factorial times n minus k factorial. We'll practice these formulas shortly. As I mentioned, I plan to use examples from casino gaming and other games. Poker. So in poker, players construct hands of playing cards according to rules that vary by the variant of poker being played. These hands are compared against a ranking system, with the highest ranking hand winning the deal. Royal Flush is the top-ranked poker hand and consists of Ace, King, Queen, Jack, 10 of the same suit from a 52-card deck. Lottery is a form of gambling that involves the drawing of lots for a prize. The California lottery allows the player to choose numbers from 1 to 53. Keno is a lottery-type gambling game often played at modern casinos. Keno allows the player to choose numbers from 1 to 80. Okay, let's start with calculations related to dealing cards. First, let's look at how to calculate a factorial. In this line here, I'm showing that 4 factorial equals 4 times 3 times 2 times 1, which equals 24. Excel has a function to do this calculation for us, and that function is called fact. So if I put in fact of 4, we see that Excel gets busy and calculates that same 24 for us. Next, let's look at how to calculate a combination. Recall that the formula is that n choose k equals n factorial divided by k factorial times n minus k factorial. So as an example, let's look at 5 choose 2. Well, that equals 5 factorial divided by 2 factorial times 3 factorial, which is 120 divided by 2 times 6, and that equals 10. Excel has a function called combine for doing combinations. So if I put in equals combine of 5 comma 2, Excel calculates that same 10 for us. Okay, let's look at an example. What is the probability of being dealt a royal flush? Royal flush means Ace, King, Queen, Jack, 10 of the same suit from a 52-card deck. And over here is a picture of a royal flush. Okay, let's pick that apart. 52 choose 5 tells us how many ways we can deal 5 cards from a 52-card deck. So in Excel, we would use the combine 52 comma 5, and that equals 2,598,960 hands that can be dealt. So let's put that in and see it calculated here. Equals combined of 52, 5, and we see that it calculates that same 2.6 million for us. All right, so there are 4 suits, so there's 4 of these hands. 4 out of these 2.6 million hands are a royal flush. And the 4 suits are shown in the picture over here: spades, hearts, diamonds, and clubs. Therefore, the probability of a royal flush equals 4 over 4 of the 2.6 million. So we can calculate that as equals 4 divided by combine of 52, 5. And so we see that the odds of a royal flush are very small, 1.54 times 10 to the minus 6. I often find it easier to view these small probabilities as a reciprocal. And that means that, therefore, you can expect to deal a royal flush every 649,739 hands, which is 1 over this probability. So let's see that calculated. That equals 1 divided by F21. Okay, and so that's how we get that 650,000 numbers. So again, if we just sit and keep dealing 5-card hands every 650,000 times, we would expect to deal a royal flush. Okay, this is a good place to pause and practice these Excel calculations. Next, we turn our attention to the lottery. So consider a state lottery in which the player picks 6 different numbers from 1 to 53. Then the state draws 6 numbers out of 53 without replacement. A hit is a number the player picked and was also drawn by the state. A miss is a number the player picked but was not drawn by the state. The player is paid according to the number of hits. There are prizes for hitting 3, 4, 5, or 6. Okay, here is the formula for the probability of these lottery hits. And that is the probability of K hits equals 6 choose K times 47 choose 6 minus K divided by 53 choose 6. So what we have here is we pick 6, there are K hits, 6 minus K misses. So let's begin by calculating the probability of getting none. None of the numbers that we pick were also picked by the state. Well, that's going to equal combine of 6, 0 times combine of 47, 6 divided by combine of 53, 6. And so we see that there is a roughly 47% chance that we will get none. So almost half the time we won't get any of the numbers. And let's just drag this down so I don't have to key in that whole formula each time. What we want to do next is what's the probability that 3 of my numbers get picked. All right, so I modify this to 3 and 3. And so we see that there is roughly a 1.4% chance that I'll get 3 numbers. Pretty small percentage already. Now the next question, what is the chance that I hit the jackpot? I hit all 6. The big prize. And the answer is 4.3 times 10 to the minus 8, a very small number. So again, such a small number, I like to view this as how many times do I have to play the lottery between 6 hit wins on average. So that equals 1 over the probability of 6 hits. One divided by C18. And so we see that that number is 22,957,480. So roughly every 23 million times I play the lottery, I'll hit all 6. Okay, the California lottery originally used the numbers from 1 to 49. It's interesting that they changed to 1 to 53 to lower the probability of winning. The idea is that more time between wins builds up larger jackpots, and these make the news. So this free advertising makes more money for the lottery. Okay, this is another good place to pause and practice these Excel calculations. Let's take a look at Keno, a casino game. In Keno, the player picks 1 to 15 numbers. Then the casino draws 20 numbers out of 80 without replacement. And here we can see this picture. If you've been to a casino, you probably noticed TV screens in the restaurants and other places that show these numbers popping up on the screen. A catch is a number the player picked and that was also drawn by the casino. A miss is a number the player picked but was not drawn by the casino. The player is paid according to the number of picks made and catches. So here's the formula for calculating the probability in Keno. The probability of N picks and K hits equals 20 choose K times 60 choose N minus K divided by 80 choose N. So let's practice a couple of these. Suppose I pick 5 numbers, and what's the probability that I get none of them? Well, that would be equals combine of 20, 0 times combine of 60, 5 divided by combine of 80, 5. And so there's a roughly a 23% chance that I will get none of these. And I'll just pause for a second here and go back and look at this formula because what's happening here, we notice here on this side that there are 80 possible numbers. The casino is going to draw 20. And then there are 60 that won't get drawn. So that's where these components of this combination formula come from. Okay, let's go back down to these practice problems. And I'm just going to drag this down instead of having to key in the formula. Next, I want to calculate the probability that I choose 5 and hit on 3 of them. So I change this to a 3 and this to a 2. And so I have an 8.4% chance that I'll get 3. And then finally, what's my chance that I'll get all 5? Oh. Okay, so my chance of getting all 5 is 0.0006. So again, a small number. So let's look at the reciprocal of that. So what this tells me is roughly every 1,550 times that I play the game, I'll hit on 5 out of 5 numbers that I pick. All right. A few years ago, I was in a casino in Carson City, Nevada, and a woman at the next table won at 5-pick, 5-catch casino game, and she was paid $1,150. So if you kind of work this out, the casino earned the $1,550 minus $1,150, or $400 for running that game. That seems fair to me because they're running the game and the casino. However, the next year I visited a casino in Reno. Their payout schedule showed only $750 for this same win. So that casino would earn $800. And so that seems unfair to the player. Okay, an important topic in gambling is taxes. An article in Yahoo Finance covered this pretty interestingly. In the U.S., what happens in Vegas doesn't necessarily stay in Vegas. Gambling income includes winnings from lotteries, horse races, and casinos. The payer is required to issue you a Form W-2G, which will also be reported to the IRS if you win $1,200 or more from bingo or slot machines, $1,500 or more from Keno, more than $5,000 from a poker tournament, or $600 or more at a horse track if it's more than 300 times the amount you bet. So even if you don't receive a W-2G, the IRS expects you to report gambling proceeds on line 21, which is other income of your Form 1040. The good news, if you itemize, your gambling losses are deductible, but only to the extent of the winnings you report as income. For example, if you won $4,000 last year and had $5,000 in losing bets, your deduction on the losses is limited to $4,000. You can't deduct the balance against other income or carry it forward. You have to report deduction on line 28, which is other miscellaneous income on Schedule A. So the IRS kind of takes some of the fun out of casino gambling, doesn't it? Okay, this is another good place to pause and practice these Excel calculations. Okay, this is the last set of examples that I have for you on this topic, and I consider these to be advanced topics. The first topic here is on calculating factorials and combinations. Earlier we calculated that 4 factorial equals 24. But suppose we want to calculate a much bigger number, such as 52 factorial, as part of the card deck problem. So let's just do that with Excel. 52 factorial equals fact of 52. And we see this is a huge number, 8 times 10 to the 67th power. So Excel gives us this big number. If you have an older calculator, it'll probably give you an error message or an overflow message. And we can imagine that if we tried to calculate this by hand, it's going to take a good part of our day. Notice that we can pick this apart a little bit. And that is 52 factorial equals 52 times 51 times 50 factorial. So if, for example, we already know 50 factorial, then this would be a way to simplify our work. But let's see what Excel gives us for this. In this case, so Excel gave us the same number. So it calculated exactly the same for us. And that's what we would expect. Now, suppose we want to calculate 52 choose 50. So we're choosing 50 cards out of a deck of 52. This formula is now 52 factorial divided by 2 factorial times 50 factorial. But as we just saw, we can break this down a little bit and have 52 times 51 times 50 factorial divided by 2 times 50 factorial. Now those 50 factorial, those big numbers, divide out. And we have 52 times 51 divided by 2, and that equals 1326. So we greatly simplified this calculation. Excel can, of course, do this for us. So equals combine of 52 comma 50. And we get that same 1326 with Excel's combination function. Okay, the last topic that I have for you is the gamma function. Recall this is a variant or an extension of the factorial. And we write that here as gamma of n equals n minus 1 factorial. Also, I'll mention that gamma of n plus 1 equals n times gamma of n. So this is a recursive calculation, or can be viewed as a recursive calculation as factorial is. In Excel, we have a function called gamma ln available to us, and that's because Excel wants to calculate the natural log of gamma instead of gamma itself. The log is a smoothing function that prevents overflows in these huge numbers. So if we want to get gamma out of it, then we have to raise the gamma ln to the exponential, because that's the inverse function. So let's try this. So an example here, gamma of 1, which would be the same as 0 factorial, equals and so we see that Excel gives us 1, which was our earlier we said by definition 0 factorial is 1. Now we see how to actually calculate it. Okay, this next one is gamma of 2 is the next example. And we see that's also 1, and that makes sense because 1 factorial equals 1. And finally, let's calculate gamma of 5. And we see that that's 24, and we already know that that equals 4 factorial, so we see that that's, those numbers are as expected. The thing that gamma function gives us is the ability to calculate these type numbers for non-integers. So let's look at the example of gamma at 0.5. And so that equals 1.77. So that's kind of an interesting capability that's available to us using the gamma function if we're doing analyses of that type. Okay, thanks for listening. Please practice these Excel calculations.